Hey everyone, so I wanted to review this circuit with two loops and two power supplies and show you how to build it on Tinkercad. But first we're just going to do some calculations to see what we should expect when we build it on Tinkercad. So we have two currents running through the loop. Now to do this we're going to use the mesh current analysis. So let's set up KVL for this equation. But first I noticed that these two resistors are in parallel, so I want to simplify that. So I want to write R equivalent, and that's just going to be the product of R1, R2 over the sum R1 plus R2, and that's going to be about 2.11 kilo ohms. Okay, great. So now let's write the, now that we've simplified that, let's write the KVL for the left loop. So starting off, let's start walking from here. So I'm just going to write some arbitrary positive and negative signs on here just to make things simpler. They're completely arbitrary. Here we go. Oh, wait. This should be positive and negative. All right. So this will just make things simpler for us. So starting off, we see we have 15 volts, negative 15 volts because of the negative sign here, plus the current. Now this current splits into two, and then but we can write it as, for now, just the current I1 plus times R equivalent. And down here we have these two currents combining, so plus R4 times R I1 plus I2. And of course we're going to be calling this I1, and this is going to be I2. And this is going to be 0. So we have the first equation, and let's do the second equation for the right loop. So we could start here. So we go negative 10 volts plus I2, 1 kilo ohms. Well, let's leave it at symbolic first, and plus R4 times I1 plus I2 plus R5 times I2, and this is equal to 0. Okay, let's substitute the numbers that we can and see what we simplify to. So for the first equation, I'm just going to I'll just rewrite it. So we have 15 volts, negative 15 volts, plus I1 R equivalent, which is 2.11 kilo ohms, plus R4, which is 2.5 kilo ohms, times the sum of I1 plus I2 equals to 0. Okay. Second equation, we have negative 10 volts plus I2 times R3, which is 1 kilo ohm. Okay, plus R4, which is 2.5 kilo ohms. I1 plus I2. What do we have? R5, which is 2 kilo ohms, times I2 equals to 0. Okay, so I'm just going to distribute. So for the first equation, it's going to be negative 15 plus 2.11. Well, it's kilo ohms, so I'll just do I1 plus. So of course the signs for these are ohms. You don't need to write them down, but if it helps you keep track of your units, go ahead. And of course this is a small I2. So this simplifies to 2500 plus 2110. That's 4,610 ohms times I1 plus 2500 ohms times I2 equals to 15 volts. Okay, so that's our first equation that we need, and then we can do the same thing with the second loop right here. So we're going to have 1000 ohms I2 plus 2500 ohms I1 plus 2500 ohms I2 plus 2000 ohms I2 equals 10 volts. Alright, so now we can simplify. Oh, I missed the ohms here. So let's simplify this. This goes to 3500. Oh, no, that's, hold on, that's I2. This is I2. I2, I2. Okay, so the sum of those is equal to 1000 plus 2500 plus 2000, which equals to 5500 I2 plus 2500 I1 equals to 10 volts. Alright, so now we have these two equations that we can substitute into one another. So, well, let's see which one we want to do. Just going back here to check that my work is correct. 1000. Yes, yes. Okay, everything looks good. So I'll write this in terms of I1. So this equation becomes I1 is equal to 10 volts minus 5500 I2 over 2500 I1. Well, no, just 2500 ohms, sorry. So 10 volts minus okay, so we have this equation now, and all we need to do is plug this back into here. So we are going to have 46110 10 volts minus, of course this is ohms, 5500 to 2500 ohms plus 2500 ohms I2 goes to 15 volts. Great. So let's see what we get. Well, let's 46110 divided by, so we have 1.844 times 10 volts minus 5500 ohms I2 plus 2500 ohms I2 equals to 15 volts. This becomes minus 142 ohms I2 plus 2500 ohms I2 equals to 15 volts. So that means that this simplifies down to 3.44 volts equals to 7642 ohms I2, which means that I2 should be 4.50 times 10 to the negative 4 amps. Otherwise it is 45.01 milliamps equals to I2. This should be, sorry, I always get my scientific notations mixed up. So this should be 0.450 milliamps. And we just need to substitute this back in here. So let me do that real quick. And for me, the calculation I got is I1 is equal to 3.01 milliamps. And let's just, for good measure, figure out the current running through R1 and R2 individually. So we know that I1 is equal to 3.01 milliamps. So current division, well, what is the current running through R1? R1, the resistance is 3.6 kilo ohms, and R2 is 5.1. So let's just note those down. And the current running through R1 is actually going to be R2 over the sum of R1 plus R2 times I1, which is going to be 5.1 divided by 3.6 plus 5.1 times the current I1, which is going to be 1.76 milliamps. And we do the same for R2. It's going to be the other resistor R1 divided by R1 plus R2 times I1, which should give you 3.6 divided by 3.6 plus 5.1 times 3.01. So it should be 1.25 milliamps. And the sum of these should add up to 3.01, and I think it does, yes. So the sum does equal to 3.01 milliamps, and that's how we know that this is correct. Alright, so now let's find the voltage across all the resistors. We know that V equals to IR, so it should be pretty easy for us. We already found the current running through I1, I2, and then the currents for these two resistors. So let's try it out. R1 is 3600 ohms times the current, which we found was 1.76 milliamps, and that gives us 6.64 volts. Now this should be the same for R2 because these two resistors are in parallel. So let's try it out. Let's see, 5,100 times 1.25, it gives us 6.38 volts. And they're about the same. I think there might have just been some rounding errors that happened. So we can see what the actual voltage is when we measure it in Tinkercad. Let's do R4. The current running through R4 is the sum of I1 plus I2. So 2,500 times the sum of I1, which is 3.01 milliamps, and I2 is 0.45 milliamps. And the voltage across R4 should be 8.65 volts. Great. Now what about R3? R3 is just 1000 times I2, which is 0.45 milliamps, which is about 45 volts. And for R5, 2000 times 0.45 milliamps is 0.9 volts. Alright, let's see if this all makes sense. So let's do KVL. The sum of the voltages across these resistors should be the same as the power supply. So let's do 0.9 plus 0.45 plus 8.65 it's exact. So this is exactly 10. These all added up. Let's do the left side to verify. I'm just going to take the average of these, 6.36 and plus 8.65. Now when I add up the voltage in this loop, it gives me 15.01 volts. That's about the same. There's some rounding errors, I think. So we know that these values are what we should be getting when we put these into Tinkercad.